Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed.
Welcome to our video presentation of hydropower. I will show you briefly what we will talk about today. The structure. At first of all, we will show you quick the history of hydropower. Then, general informations. What types of hydropower are there? After that, the potential of water energy. Next, we count the largest producers of electricity from water. And last but not least, our conclusion about hydropower. First, we come to the history of hydropower. The history of hydropower goes back a long way. Historians believe that it was already being used in China 5,000 years ago. Other cultures along the Nile, Euphrates, Tigris and on the Indus River used the first water-powered machines in the form of water wheels to irrigate fields 3,500 years ago. At the beginning of the 20th century, the first mills were then used to supply electricity. Today, electric power is produced by generators. Now we come to the general about hydropower. Hydropower uses the kinetic energy of water. Kinetic energy occurs wherever there is a difference in height. The water is in the direct to a turbine that drives a generator, which then produces electric current. There are two types of power plants, the storage power plant and the run-of-river power plant. Storage power plants are dams that dam up rivers and lakes. By damming them up, a difference in height create, or artificially higher basins that act as a kind of energy storage. Both of methods store water until there is an increased energy demand. Then the water is drained and electricity is generated. For example, Three Gorges Dam in China or the Goldisthal pumped storage plant in Thüringen. Run-of-river power plants are used on rivers or streams and dam these up. In the most cases a difference in height is also generated here and no water stored. This kind of energy production is much cheaper and doesn't mean such a large intervention in the nature. But the energy potential is much lower than in the storage power plants, because much less water is used and therefore the less kinetic power is generated. At all cases, turbines are set into turning motion by flowing water, similar to window power. This resulting kinetic energy is fed into generators and converted into electrical energy. The types of turbines used are selected according to the drop height and the amount of water available. These kinds of turbines are in application. Kaplan turbine looks like a ship's propeller. Francis turbine, one of the oldest turbine types. Pelton turbine for high heats. Cross-flow turbine, low pressure system with strongly variable water supply, and last but not least, the Joinville turbine.
Now it's time to tell you something about the potential of hydropower. The two different types of hydropower plants also have different functions. The run-of-river power plants serve to supply the base load of electricity. The storage power plants, on the other hand, serve to cover the expensive peak demand. Overall, the share of hydropower in the public electricity supply is about 4%. More than 600 hydropower plants of the energy supply companies supply the public grid with their electricity. In addition, there are thousands of private small hydropower plants which also supply their electricity to the public. It's estimated that the use of hydroelectric power can be increased by 15 to 20% by optimizing and modernizing existing plants and building new ones. However, the construction of new power plants has its limits, because every new dam and every new barrage means an intervention in nature. But the possibilities for reactivating small, decommissioned power plants are far from exhausted. In Germany alone, there are thousands of sites which could be considered for reactivation. Nevertheless, hydropower plants have an undisputed benefit for the environment. Their screens and filter systems remove waste and refuse from the water. The turbines supply the water with oxygen for self-purification. The calm headwaters create wetland biotopes, and the controlled water flow ensures a largely constant water level. However, the potential of hydropower is far from exhausted and could be a much bigger factor. Here are some general informations about the producers. Hydropower is generated worldwide. The countries which produces the most electricity are China with 652.1 terawatt-hours per year, Canada with 369.5 terawatt-hours per year, Brazil with 369.5 terawatt-hours per year, and the USA with 250.6 terawatt-hours per year. Germany is far behind, with just 22.9 terawatt-hours per year. For your understanding, Germany consumed 527 terawatt-hours in 2018. This means that in 2018, 23 times more was consumed than produced. The largest storage power plant is located in China. It's the well-known Three Gorges Dam. In German, it's named Drei-Schluchten-Staudamm. It has been open since 2003. The length of the reservoir is 663 kilometers and the width is 1.6 kilometer spread over 3 gorges. It stores 39.3 cubic kilometers of water. For comparison, this is about 3/4 of the amount of Lake Constance and about 20 times the amount of Lake Chiemsee. It produces an annual generator output of up to 84.7 terawatt-hours, and so it produces more than 3 times as much electricity as all of Germany and as much as 12 nuclear power plants. However, the edification of the dam not only has a huge energy supply, but also disadvantages. Huge areas of land were flooded for the damming of the Yangtze. Many people lost their homes and were not sufficiently or not at all compensated. The largest storage power plant in Germany is the Pumpenspeicherwerk Goldisthal in Thüringen. It's open since 2003 too. The storage size is 8,480 megawatt-hours and it has a capacity of 18.9 million cubic meters, which is about 2,000 times less water than in the Three Gorges Dam. Unlike the Three Gorges Dam, there are no lakes flowing onto the dam, but an upper basin has been built here where the water is stored. The basin is filled with water from the nearby river. The water is pumped 300 meters into the upper basin. The pumps get their electricity from the grid and are switched on when the grid load is low, for example at night. The water is temporarily stored until there is an increased power consumption, for example in the morning or evening. The resulting drop energy is used to drive turbines, which are connected to a generator. This generator then produces electricity. The function of a storage power plant is to store electrical energy in form of water and to convert this energy back into electricity when required. Finally, here's the conclusion. Hydropower has many advantages, but unfortunately also a big disadvantage, which should not be neglected. Hydropower has the advantage of being available around the clock. Their sieves and filter systems remove waste from the water, the turbines supply oxygen, the calm headwaters create wetland biotopes, and floods can be prevented by the large dams. But likely the biggest disadvantage is the construction of the dams. They flood huge areas of land and damage animals and people. To conclude this video, here is our opinion on hydropower. We think hydroelectric power is a great thing, because besides pure energy production, it has many other advantages, such as the purification of water. The mere fact that the Three Gorges Dam generates as much electricity as 12 nuclear power plants makes us in favor of promoting and expanding hydroelectric power. Thank you very much for your attention and have a nice day.